Can anybody hear me?
Yeah, I think we're streaming now.
Yeah.
Okay, great. Fantastic. Okay. Sorry for the delay, people. We are having some trouble with technical difficulties. Has everybody joined so far? Chris, Karen?
Yes, I'm here.
I'm here as well. Is Anthony here?
I'm back, yeah.
Okay.
Should I try going live right now?
We're already live on YouTube, you amateur.
What was the problem?
You!
Right, well, we're now live on OBS as well, so we're on Twitch as well, right? We're good.
Yeah, well, we're only the Zoom feed is now live on YouTube, so we're good to go.
So we can just okay. So let me just get this to here. Okay. We're live on YouTube. The problem I've got is the webcam's not working on OBS now for some weird reason. That's okay. We can go on without it. I'll have to just improvise. All right. So today's discussion or today's webinar is to do with the force the level experiment, force the level test, in which we're going to have a back and a forth questions and answers session. The idea is that we're going to try and force a level line and test to see whether or not we can test the earth in which we live upon. Today we're joined by Karen B, we're joined by Chris Van Matre, we're joined by Mike Kavanagh and Sandor, plus a few invitees. And the idea is to engage in conversation with regards to the method that's to be applied to see whether or not that which we're doing is good science or good technique or good practice. We don't want to get too dogged down in the terminology, but what we do want to try and achieve is a consensus with regards to what is the correct thing that we're trying to achieve and how we're actually going to do that. Chris Van Matre, can we have a mic check to make sure that we can hear you?
Check.
Yes, that's working. Karen, are you still there? Can we hear you?
I am. Do you hear me?
Yes. And Mike, are you there? Can we hear you?
Of course you can hear me.
Everything's working, it seems. Right. So, Mike, do you want to take over and see if we can get this conversation started? Because we're running late.
Yes. What I've also noticed is that because of our delay and our technical difficulties, that our attendees have not joined yet. But we'll start anyway. There have been lots of questions about our force to level document that we published 2 weeks ago. Some good, some not so good questions, some good tips and pointers. And what we like to do here now, and what I would actually more like to do, is actually have a surveyor panel on the other side commenting on what we're saying, but unfortunately they are not here, so we'll have to do it on our own. I'm very confident we will manage just fine. But we've been having discussions with people like Jesse Kozlowski, for example, who is a certified licensed surveyor in the United States. Some of his colleagues or friends have also chimed in on the discussion. One of them was a gentleman by the name of Paul James, very kind and smart individual who has raised some valid questions with regards to the method that we're applying. And somebody named Tim Good has also sent in a good list of questions that we would like to address and answer here. As I said, it's kind of shame that these people are not here yet. Let me check the attendee list again. No, they're not here. But regardless of that, we will just start with addressing some of the questions that have come up in either email or commenting on our videos. Let me just get one of the list with questions with me, so I have the right list in front of me. Bear with me.
We need an introductory paragraph to describe what the Forster level experiment or the test is. What is it we're trying to achieve? How is it being done?
That's very good. Yeah, Forster level is we designed a method that we think not only detects curve but actually very accurately measures it if it's there. All the other surveying methods that we have seen so far all derive or assume curve based on either an angle change or a change in vertical elevation, vertical drop, so to speak. But none of them actually measure the curve that is supposed to be there. And it is my opinion, and I think most of the panel members on the FECORE side agree with me on that assuming curve based on a derivation is fallacious, and we would like to see a method, or we would like to develop a method that actually measures that curve, if it's there, very accurately with high precision. And for that, we developed the Forster level method with 4 surveying rods and a digital auto level. The 4 surveying rods are placed 40 meters apart, and readings are taken from every rod, some balanced, some unbalanced. The balanced measurements are used to do the actual measurements, and the unbalanced measurements are used to find additional information or data, use it for data analysis, like comparing it to environmental refractions and why there's actually a difference there between balanced and unbalanced, and see if there's a correlation between atmospherics and that discrepancy. And we've done a preliminary test with 3 rods, and the results we've published a couple of weeks ago on our website. They were considered to be highly controversial because nobody on our side exactly anticipated this result, and that's what made it so interesting for us to actually proceed with this and improve on it. So we can actually get to an empirical result with regards to if the curvature is there or not. And for that, we've published the PDF, and there are some good questions that have arisen so far, and we would like to address those right now. Does that make it clear for everybody, or?
The idea is to get an agreed methodology.
Yes.
Correct.
Yes, that both sides agree on. When I say both sides, I obviously mean the globe skeptics and the globe believers. And if both parties can agree on a method that will actually detect curve if it's there, then the results will be undeniable for both sides, either way.
Okay. So
okay, let me just get the questions. Here they are. Now, I'm just going to read the questions, and then I'm going to hand it to Sandor or Chris to actually answer them. So I'm not the only one that's actually doing all the talking all the time. This is from a gentleman named Tim Good. He was supposed to be here today, but he's not here, unfortunately, probably due to the fact that we were so late. Apologies for that, but I'll just read this entire email and then the questions will follow. I am not sure I will be able to attend. Well, that's a disclaimer. In the interest of full disclosure, I am not a flat earth believer. I'm very curious how this experiment will turn out, and I'm interested in it being accurately conducted. Well, so are we. So in the meantime, if you don't mind, I'll share some comments and questions which I hope you agree are good questions to consider in the interest of achieving a valid result. Question number 1. I noticed that every height measurement in the FECORE report is paired with a distance measurement, but distances do not appear to be used for anything. The ideal distance is 131.2 feet, but the measured distance between the rods do not equal 131.2 feet. They are off by 2 to 5 feet on most measurements. Is the reason for this understood? Chris or Sander, can you address that?
Yes, I can address that. The measurements in the document were from the level to the rod itself. Now the 131.323 feet and the 40 meters is the distance that was between all 3 rods. So the distance in there was the distance from the level to the rod, and not the distance between the rods themselves, which was 40 meters or 131.23 feet.
Okay. Question number 2. It's a similar question. Each pair of rods had their separate distance measured twice, A to B and B to C. But those measurements are not the same. Do you know why? Chris or Sandor?
When we did this, what we did is we set up the level and read all 3 rods. Then we leapfrogged the level and the rod at the same time, which on this next test with the 4 rods, we're going to read all 4 of the rods from 3 different positions before we move the level again. Something
Correct.
that we learned in the first test that we need to change in this next one.
Yeah. The new method is going to be we're taking the first measurement on P1 between rod A and B, but we're also measuring all the other rods. We're then moving the level to P3. That's between the C and D rod, and then we'll measure all the rods again. And then we put the level between B and C, that's on position 2, so it's exactly in the middle. And then we'll take all measurements again. And once we've done that, then we'll start moving rod A to position A2. And then the level is basically on the same position as it was in P1, and we can start the entire cycle all over again.
Correct.
That's the plan for now. Okay, next question. What was the exact Dini model and mode used? If it's the highest accuracy model and making electronic measurements using the barcoded rods, the distance accuracy should be 0.1%, if I understand the manual correctly. Some of the measurement errors appear greater than 3%. Is that correct?
We had the 0.3 Denny level, and I did not turn the level to the 10,000th of a foot measurement, so we have some rounding errors, which we'll correct in the next test.
Correct, yes. Yeah, it's good for people to understand that the first preliminary test that we did was actually just a test. We weren't even supposed to or not planning to release these results because we're just testing the method for ourselves before we would actually implement it into a full-scale test. But since we did get results back that we could use, once we put that back into our calculation sheet and we saw the results, well, it took us 4 months to actually verify if what we did was actually correct with the mathematics, etc. But once we found out that that at least we could not find any flaws in our method, we decided to publish it anyway. So people with or other eyes could possibly see if there are obvious flaws that we might have missed or errors in our calculation sheet. But so far we've had some arguments raised. There was one error found in our calculation sheet, but that had nothing to do with the measurements themselves. It was related to the expected Earth curve drop, and that we changed that already, and that's going to be released in a revised version in the PDF after this live stream. So I'll just skip on to the next question. The DINI has a built-in Earth curve correction, which can be turned on or off. Was it on or off during your test?
It was on.
Yes, it was on. And we are of the opinion that that is the exact reason why we got this result. Because if you're compensating for curve while you're actually trying to look for it, that's probably not the right method to do it. So on the next test that we're going to do, we're going to shut all those features off. No corrections for refraction, no corrections for curvature. So we actually have a level line which we can compare the geopotential to. Am I saying that right, Chris?
Yes, yeah. And it's also possible that that is the reason why we got these concave measurements, because of this correction in the DINI itself.
Yes, yeah, I'm of the same opinion, but I'm not sure about that. But I think that is the reason why we got curvature back, because we're correcting for something that's either not there or yeah. Okay, next question. The DINI also has a refraction correction parameter. What value did you use during your tests?
The refraction correction is actually together with the curvature correction. So when you turn it off, you turn off both.
Okay. Well, that answered that question. Do you have anything to say about that, Chris?
No, I believe that's correct. The only other one would be the refraction coefficient. And the refraction coefficient is put in there after you do the peg test. You peg it out to figure out what your refraction coefficient is supposed to be. And when I rent the equipment, they certify that it's ready and columnated and accurate when we take it out into the field. If I was using this instrument on a daily basis where it was being bounced around in a truck and hadn't been serviced, then we should have done the peg test and actually entered in the refraction coefficient to make sure that it was columnated. But it was certified to be columnated and ready to go when I picked it up.
Okay, great. Then last question from Tim. The method you used with the 3 rods at the positions A, B, and C is very similar to the line of sight calibration procedures embedded in the DINI. Was the DINI calibrated using one of those procedures before the test? And if so, which one? And what value of C was used during the test?
I think I just covered that question.
Yes. Okay, that was the last question from Tim. Let me check if Tim has already joined the webinars. No, none of the attendees are here. Shame, but okay. There was another, or at least some good tips that Mendel, I'm not sure what his exact name is, but he said that we should put the DINI as high as we can to avoid the terrestrial refraction influence, and that is something that we would probably do. I'm not sure what was the level that you put it on the preliminary test, Chris. What was the height of the DINI?
I would say it was approximately 4.5 or 5 feet.
And what would be the maximum height that we could use?
I would have to say the maximum height would probably be around 5.5 feet, because I've got to be able to look into it, and I'm only about 5'9". Yeah, so I can set it up at maximum eye level.
You're only 5'9", Chris.
Yeah.
Well, you must look like a midget compared to Bob then.
Exactly. Yeah, you're limited by how tall you are.
Yeah. Well, that's obvious. You know, using a step would be, I think, a little bit too much, but.
So yeah, we'll try and make sure that we set it at maximum height on this next measurement.
Mike, I think somebody also had a comment why we are using so many people, like 4 people on the rods and 1 for the measurement. I'd like to address that.
Yeah, sure. Go ahead. Go ahead.
That I don't think that today there is a limitation in technology of how many people we use. So if somebody does not want to use 5 people, then he will not do the measurement. But I don't think it's a reason why not to do this measurement.
I didn't really understand the question. What was the question?
It was just an opinion from one of the surveyors that today they use 1-person measurements, and now we are proposing a measurement that needs 5 persons. And
well, we're not saying that you should use 5 people. You could do this on your own, but it will just take 5 times longer than if you do it with 5 people.
Exactly, and also if there's a bigger team, then we move faster forward. So that's our goal to cover.
Yeah, we got a quite a distance to cover. If we want to cover 2 miles, then doing that on your own would probably end up you being busy for 24 hours. And if you have personnel there that can actually move the rod, take the readings, write down all the readings on data sheets, that saves a lot of time if you spread that load. And that's the reason why we use a large group to perform this test.
Yeah, and we anyway need photographers taking the pictures and some other people helping out. So it's not going to be about how many people we use.
No. And the reason why we have so many people there is for efficiency, but we're also going to document everything. So we need camera people there. And as soon as we've done this and we've compiled this into another document that we're going to release, we're going to ask for the opinion of licensed surveyors from all around the world. We're going to send our PDF to as many universities and national surveying institutions as we can find, and invite them to a similar platform like this, a webinar. And hopefully we'll get at least 50 people there that know what they're talking about, professor level or at least national surveying institutions representatives. And if they do not see any obvious flaws in our method, then what we're going to do next is try and implement this test or get it done by a licensed and certified geodetic surveyor. And those results will then be in the books, official. And what happens from there is up to the surveying community themselves if they think it's either bogus or something that definitely needs to be looked into. And I think the latter is if you're an intellectually honest person and you see that there is nothing wrong with the method and the results that come back are controversial, that shouldn't matter or shouldn't resist you from trying to establish fact. And that's exactly what we're trying to do here. We're trying to establish fact. We're not trying to derive curvature from observations over long distances with optical instruments that are susceptible to these flaws. We're trying to use the shortest distance possible. That's why we put 40 meters between the rods, and we're taking readings between all those rods, and then we're moving the entire setup one step at a time. So we keep all the distances as short as possible to eliminate limiting factors like refraction, etc. But we're still going to try and accommodate ourselves to that. We're taking environmental readings at every measurement that we take, at different heights, at every rod, so we know or we have everything well documented. And if there is some correlation between refraction and, for example, an unbalanced shot, then with all those readings, we might or we probably will find that correlation, because now refraction is always a result or an effect of something, and that something is atmospheric. And maybe, and I hope that we will actually find some kind of correlation, which we will see in our diagrams as soon as we put all the data in. So yes, that's my part. Does anybody else have something to add to this, or questions that they may have come across so far?
Yeah. What's the position with regards to potential legality? I've seen some chatter about whether or not this is like legal or not legal with regards to it being licensed or unlicensed, conditions of license.
Okay, let me address that real quickly. We are not hired as surveyors. We are performing research, and research does not need licensed people to perform it. When we are actually hired to do surveying tasks or jobs, that is a contract-based agreement. And if you have a contract-based agreement, you need to be licensed to perform it. And we are not licensed. We acknowledge that. We know that. But doing research does not require a license.
Exactly.
And it's also not unlawful to use surveying equipment on public property.
So there's no risk of illegality in anything?
Absolutely not. No.
And to just add to that, I have acquired a licensed Colorado surveyor that is going to look over the information that we're doing.
Fantastic. Yeah, you said that to me yesterday, Chris. So even though it's not necessary, we're still trying to accommodate for that.
Exactly.
Anything else, Anthony, from the chat maybe?
Will it be repeated more than once?
Yes, of course. We're still in the testing phase. We had our preliminary test. The test that is coming up in 3 weeks is just another test, because we want to see if we either get the same results or something totally different. The first result that we got back, as I said, nobody on our side expected that, and it made me very, very interested in this particular test myself, because as I said, we've been trying to find a flaw in our own method for 4 months, and we were not able to find that. So, you know, our results stand as it is. The results are concave, and although it's controversial and unexpected, you know, the result stands as it is, and that's why I want to do more tests to see if now the improved method will still render the same result or something totally different. But it is our contention or our opinion that this test that we've developed is the only surveying test out there that will actually physically measure the curvature if it's there, and not derive it from angle change or vertical drop. We're not measuring slope, we're measuring the arc of geopotential between 2 points.
Will this be written up and presented as a journal for the purpose of peer review?
That is our intention, but you know, peer review. We're developing a measurement method, and it's not really susceptible for a peer review. Although we are looking for actual peers from universities and national geodetic institutions to actually review what we have presented, but I'm not sure if our results are eligible for peer review in a way that it's not scientific in nature. Anything else?
Yeah, let me go back and address the 4 people that are that we need for the rods. The reason why they need to be there is these rods have level bubbles on them, and they also need to ensure that they're perfectly level throughout the measurements.
Okay. Any more questions from the chat, maybe, Chris? Or Anthony, sorry, Karen?
I don't see any questions in the chat. If anybody in chat has a question, you can go ahead and post it right now.
Yes, yes, please do, because the reason we published this result is because we want feedback. We want to know if we did something wrong and where we did it wrong. And I'm not afraid to admit fault in any of this, because I do not proclaim to be a surveyor. I'm a mechanical engineer, and I have 0 field experience as a surveyor, but I'm not stupid. I know how it works, and I'm not unable to understand the methods used, and I do. So for that reason, we developed this method, because there's not a method in surveying now, as far as I know, and correct me if I'm wrong, that actually physically measures the curvature instead of a derivation.
I guess the final words would be to invite people to pass their comments, thoughts, and criticisms of the method, because we need to know that we're not making mistakes before the mistakes may or may not be made, right?
Yeah, well, we've had our PDF up for 2 weeks now, and we have been getting some comments and feedback on what we may have done wrong. But as far as I know, I've addressed all those issues, and the pointers and tips that were made that actually do improve on our method are going to be implemented. So we're improving still, but if anybody sees an obvious flaw in our method that we do not see, then please do contact us and share that with us, because we want to know before we actually start performing this test.
There's a question in chat that says, what will you do if you find convexity? What would you think? And will you make another test?
If we find convexity, we will publish it just as we publish concavity.
Yes, and I think it's important to point out that we are measuring a certain distance on this plane, so on the field. So that means that result that we get refers to that exact location. It could be concave, it could be convex in different places, and it could be flat overall. So what we need to do is do a lot of experiments that show the tendency, which way it's going, and then we will reach a certain point where we can definitely say shape these geopotential surfaces.
Yeah, well, we could also do a comparison. You know, if general surveying methods measure vertical drop on, say, one location, we could put that to the test by doing the same point-to-point measurement with a force level test and see if the curvature is actually there. Now, and that will display the discrepancy between the 2 methods, and one of them is then at flaw.
Yes, and we also derive the undulation data from these measurements, so we can precisely map how exactly this geopotential surface looks like. In none of the models it should be completely curved or completely straight. It has its ups and downs, and that's what geoid undulation actually means, that it's not exactly on that spot where it should be.
Yes, exactly.
Will this be open to anybody to come and witness the event?
Yes, Bob has put out a request, I think 2 weeks ago on Globebusters, that as soon as we publish the date and the where and when, then everybody that wants to see is invited to come and see, as long as you're not interfering with our measurements. So yes, it's open to the public.
And it's pretty wide open, so there'd be lots of viewing areas for people to stand back out of the way and observe.
Yeah, well, observing, I think observing it would be quite boring. You know, you're just looking at people dragging stuff around. So there's, you know, it's not really interesting. But if you want to, you know, see if we're actually doing the stuff that we claim to do, then you're welcome to see that. Absolutely.
Just one other question. Does the equipment being used require some calibration certificates? And if so, will they be definitely guaranteed, promised to be in date?
Yes. I've requested that, they usually don't, but I've requested that they give us documentation that it's been calibrated and it is in good working order before we take it out.
Yes, someone is asking if the test is parallel to water.
No, and that's one of the ideas that I had myself too. Once we've done it in Colorado, I would like to do this here in the Netherlands. We have a dike here in the north that's called the Afsluitdijk, and that's it has a bicycle lane next to the sea that's on the north side of that dike, and we all know what the claim is about water, and that dike is 30 kilometers long, and a test there should definitely show if water bends or not, because we have the reference point of the sea next to us. Anything else, guys? I don't want to make this too long because I'm actually sitting in a restaurant with my family having dinner. So
I can't think of anything else myself, no.
Me neither.
It's a shame that our surveyors were unable to join today. But that's probably
you can't even blame me.
Yeah, I can blame you, and I am blaming you. You said what's wrong, and I said you.
It was timing, I think. Anyway, let's wrap it up then.
Yeah. I thank everybody for watching, and if you have some tips, advice, or comments on what we've published so far, then do not hesitate to burn our socks to the ground if you found something bad. I will not be ashamed to admit if we made a mistake. So please do go through every little detail and see if there is error in our methods.
What's the best way to voice your concerns or objections?
Please do send us an email. I don't want to get too caught up in YouTube comments, because that can take me a lot of time to actually answer and address those all. Plus, I've turned my notifications off from YouTube because I get spammed with messages. So yeah, the best chance to actually get a hold of us is use our email address or our contact form on our website.
Okay, let's wrap this up and just be aware that everybody's invited for their comments, thoughts, suggestions, criticisms via email, and we'll do the best that we can to address everything that comes our way. In the meantime, I'd like to thank everybody for joining, and I hope this has been constructive. Apologies for the late start. Not quite sure what went wrong, but I'm getting blamed for it. But in the meantime, let's everybody put our thinking caps on and watch the test results come through and see what happens. So thank you all for attending. This meeting is now drawn to a close. We shall catch you all in the next 3 weeks' time, when we'll be repeating the next webinar or broadcast, and we'll catch up with you then. Thank you all.
Yes, thank everybody, and bye-bye.
Mike, you've got to turn it off YouTube.